Hey everybody, we are going to look at some conduction with pop cans. This is in your OneNote and I sent it to you earlier today. So let's look at this first scenario here. It says, two neutral pop cans are touching each other. A negatively charged balloon is brought near can X, which is picture 1. The cans are separated while the balloon is nearby, so picture 2. And after the balloon is removed, the cans are charged, picture 3. So we have to figure out at the end of the process, what's the charge of can X, what's the charge of can Y, and what's going on with the subatomic particles. So first thing, let's take a look at this first picture here. Well, it said that can X and can Y were neutral, which means that they've got an equal number of protons and electrons. Let's just say 2 protons, and we'll do 2 electrons per can. Let's draw these in here. Okay. Now, we know that negative things do not like other negative things. So when I bring that negatively charged balloon close to those pop cans, okay, what's going to happen is those negatives are going to run away. They're going to go as far as they possibly can. So they're actually going to go this way. Okay, so I'm going to just erase these and put them all over here. Oops, lost a proton. Okay, so they're going to run away. So in picture 2, it says that while the balloon is still nearby, the cans are separated. Okay, well, that means that those electrons stuck over there in can Y. So if I were to draw my protons here and draw my protons here, there's a buildup of electrons in this can. Okay, so they're just in there already from picture 1, and then when I separated them in picture 2, they stayed there. Okay, so then after the balloon is removed, the cans are charged. So if you were to draw your charges back on the cans again, you would have, oopsie, wrong color, you would have protons here and here, because remember, protons don't move, and you'd have electrons on here. So labeling these pictures is really important, because then what you can do is you can easily answer these questions. So at the end of this process, number 1 here, what's the charge of can X? Well, at the end of the process, we're going to be focusing on picture 3, this guy. Okay, what's the charge of can X? Well, all those electrons ran out of can X and moved to can Y when I brought that negative balloon there. So the charge of can X at the end of the process was positive. Number 2 says, at the end of this process, what's the charge of can Y? Well, can Y got all of those electrons from can X when that balloon was brought by. So can Y is negative, because you can see if you look at the picture, it's got more of those little red electrons than the protons. Okay, and then it says in the above example, the protons, neutrons, or electrons moved toward or away from the negatively charged balloon. Well, first part there, do protons leave? No. Do neutrons? Neutrons and protons are in the nucleus. They don't move. Okay, so the only subatomic particles that move here are going to be those electrons. And we know that that balloon was negative, and like I said, negatives and negatives don't like each other, so those electrons moved away from the negatively charged balloon. Okay, so let's look at the second scenario here. Two neutral pop cans are touching each other, and this time it's a positively charged balloon is brought close to can X, which is picture 1. The cans are separated while the balloon is nearby, which is picture 2. And then after the balloon is removed, the cans are charged, which is picture 3. Okay, well, let's, again, draw our subatomic particles here. So we'll do the same as before. So we'll have protons and protons. Okay, so let's pretend that, this is before I brought that balloon close. Okay, so the cans are neutral. Well, then picture 1 happens. I've brought that positive balloon close. Well, this time, Remember, protons don't move, but negatives and positives like each other. So what's going to happen is these electrons are going to go that way. Okay, so let me erase these guys. And I'll stick them on this can here. Okay, so now can X has got 4 electrons and 2 protons. Okay, well, I kept that balloon there, and I separated can X and Y in that second picture. So again, let's draw our protons here. And let's put our electrons on can X. Okay, so you can see that there's definitely a buildup of charge on can X. And then it says after the balloon's removed, the cans are charged. So I'm going to copy those charges from picture 2 onto picture 3. So again, draw my protons here. 1, 2, 1, 2. And then I'm going to put my electrons on can X. Okay, so like I said earlier, drawing the charges is super important because it's going to make it much easier for you to answer these questions. And on your exam, drawing pictures, drawing charges, draw everything. So that way you just make it easy for yourself. All right, so at the end of this process, what's the charge of can X? Well, can X was closest to that positive balloon. Can X was the one that took on all of those electrons. And if you look at picture 3 here, okay, if we focus on this picture, at the very end, can X got 4 electrons and 2 protons, which means that it has more negatives than positives, so it's going to be negative. At the end of this process, what's the charge of can Y? Well, the electrons left can Y and moved to can X, so can Y at the very end is going to be positive. And then it says in the above example, the protons, neutrons, or electrons moved towards or away from the positively charged balloon. Well, negatives and positives like each other. And the only thing that moves, the only subatomic particles that move are electrons. So in the above example, the electrons moved toward the positively charged balloon. You will definitely see these types of questions on your exam.